Hello guys, what's up? I am engineer AK, and today it's the sixth lecture of the chapter 2, metal structure and crystallization. In today's video we will do some more examples on Miller indices, but these examples will contain some new concepts that you people should know, right? So let's get started. So in this example 1, we can see that if I'm taking this plane, right, this one, so it is not if I take this is as my origin, right? So this plane, if I move in x-axis, so it is parallel to this plane, right? It is not cutting this plane, right? Similarly, if I move in y-axis, right, so this is not let me draw it here. I'm taking this as my y-axis, and I'm taking this as my x-axis, and I am taking this as my z-axis, right? So if I move in z-axis, so still this plane is not cutting, so I mean its Miller indices will be 0, 0 and 0, right? Like wait, let me change this. Okay, so it will give infinity, right? This will also give infinity, right? And this will also give infinity. So if I take then reciprocal of it, so it will give 0, 0, 0, right? So in this case, if the plane is passing through origin, then what you will do, that as we have studied before, that all the plane parallel to this plane will be having the same Miller indices, right? We have studied it. So this plane and the plane above it, these two planes are parallel, right? So if I find the Miller indices of this plane, so that will be the Miller indices of this plane as well, right? So that's why I can shift the plane parallel to it, right? So now if I take this as my origin, right, and if I move in x-axis, so it is not cutting this plane, so it will be infinity. Similarly, if I move in y-axis, so it is again giving me infinity because it is not cutting this plane, right? And if I move in z-axis, so it's cutting the plane at 1, right? So here I'm at x-axis infinity, at y-axis infinity, and at z-axis 1. And yeah, one thing another, you can take origin anywhere, right? You can take origin here, like you can take origin here, right? You can take origin here, you can take origin here, right, or here. Mean it's up to you that where you want to take origin, right? So then if I take reciprocal of it, so 1 over infinity, 1 over infinity, and 1 over 1, right? So it will give me 0, 0, 1, right? So the Miller indices of this plane is 0, 0, 1, right? Now let's move to the second example. Yeah, so this is another scenario, like sometime it is possible that the plane is a bit at the side from the unit cell, right? Like in this example, it's another kind of scenario. So how you will deal with this kind of scenario? So again, I am taking okay, let's suppose this time I am taking this as my origin, right? So we know that from here to here, right, it's 1, right? And then from here till here, it's 1, right? So from origin till here, where this on x-axis where the plane is cutting, so it's, if I add them up, so it become 2, right? So here I write it as 2, right? And if I move at y-axis or here, so it is cutting at infinity, right? And if I move at z-axis, so again it is cutting at it is infinity, mean it will be somewhere at infinity. So at y-axis infinity, at x-axis infinity. Now take reciprocal of it, right? So it become 1 over 2, 1 over infinity, and 1 over infinity. So then its mirror indices will be 1 over 2, 0, and 0. But try to remove this fraction. So in order to remove this fraction, so what you will do, you will multiply 2 here, right? You will multiply 2 here, you will multiply 2 here, and you will multiply 2 here, right? So it will cancel out, right? So and 0 multiply 2, it becomes 0, and 0 multiply 2, it becomes 0. So its Miller indices will be 1 0 0, right? We can see it here, 1 0 0, right? Now moving toward the third example. Oh, wait a bit. Okay, so in this kind of scenario, what you have to do, let me change, select this green one. Okay, so here, if let's suppose I am taking this as my origin, right, and this is as my x-axis, right, and this is as my y-axis, and this is as my z-axis, right? So if I move in x-axis, so this plane, I am finding the Miller indices of this plane, right, this blue one. So in x-axis it is cutting at 1, right? And if I move in z-axis, so it is also cutting at 1, right? And I know that in this direction it is positive y-axis, and in this direction it is negative y-axis, or y-axis, right? It's my negative y-axis. So now the plane is here, so if I move from here to here, so it is cutting the plane at -1, right? At x-axis at 1, at y-axis -1, and at z-axis 1, right? So you can either write -1, or it is also represented by 1 and a bar on it, right? You can also represent this as like this or like this, right? But if you, when you will write this in Miller indices, so you will write like this, 1 and a bar on it, right? So here we see at x-axis it was 1, at y-axis it was -1, or you can put a bar on it, and at on z-axis it was 1, right? So then take reciprocal of it, and it will give 1 -1 and 1, right? So its Miller indices will be 1 1 1 1, and yeah, we will put a bar on it, right here. So 1 -1 1, right? Okay, like this is the Miller indices of that plane, 1 1 bar, or -1 and 1, right? So let's move further. Okay, so here it's another example. So in this example we are going to find the Miller indices of this plane, right? So in this you can also take this as your origin, right? Or you can also take this one. So let's suppose I'm taking this one, right? So if I am taking this as my x-axis, this is as my y-axis, and this is my z-axis, right? So if I move in x-axis, so it is not cutting, so mean it is infinity, right? If I move at y-axis, so it is somehow cutting at 1/2, right? And if I move in z-axis, so again it's infinity, right? So here I can write as 1/2, right? Yeah, and it become 2/1, right? And it become 2, right? At x-axis it is infinity, at z-axis it is infinity, and at y-axis it's 1/2, right? So if I take reciprocal of it, so it become 1/1 infinity, 2/1, and 1/1 infinity, so it becomes 0 to 1. And try to reduce it to the least values. So what I will do, I will divide here by 2, right? You can divide here by 2, right? And you can divide here by 2. So it will again give us 0, this will also give us 0, and this 2 and 2 will cancel out, so it will give us 1. So its middle indices will be 0, 1, 0, right? And here can I 0, 0, 1, 0, right? Here I have right, but here it's 1/2, and it become 2/1, right? And it become then 2, right? And when you divide this all these all by 2, so you will get this, right? So this is another example, and this is the way how the examiners ask question in paper, right? So in this unit cell we are given 3 planes, A, B, and C, and we will find the middle indices of each one, right? So let first me find the middle indices of the plane A. So what we'll do for plane A, right? This is plane A, this triangle, right? So I am not taking this as origin, because if I take this as my origin, so then it will not cutting the y-axis. So to make it simpler, let I take this as my origin, right? So if I move in x-axis, like it's my x-axis, it is my x-axis, right? It is my z-axis, and it is my y-axis, positive y-axis, right? So if I move in x-axis, so you can see that here it is cutting this plane, right? So in x-axis it is cutting at 1, right? Now if I move in y-axis, so here we can see that at y-axis it is also cutting at -1, right? -1, because this is if I move in this direction, so it is a positive positive y-axis, and if I move this is as my origin, if I move at left side, so it is my negative y-axis, right? So it is cutting at -1, right? And if I move in z-axis, right, so it is again cutting at 1, right? So here I have written as 1, -1, and 1, right? In x-axis 1, at z-axis 1, and at y-axis -1. And then take a reciprocal of it, right? 1/1, 1/1 -1, and 1/1, so I will get 1 and -1 and 1. So this is the middle indices of plane A, right? This one, plane A, right? Now let me rub it, because it is also written here, or you can here just you can also, instead of minus, if you don't want this, so you can put a bar on it. The best way is to put a bar on it, right? Now let's move toward plane B. So if I move toward plane B, so here let's suppose now I am taking this as my origin, right? So if I move in x-axis, so it is not cutting the plane, so it become infinity, right? And if I move in y-axis, so it is cutting plane here, right? And the value here is 1/3, right? So at y-axis we will be having 1/3, right? Positive y-axis 1 or positive 1. And if I move in z-axis, so again this plane is, we can see that this plane and this axis is parallel, so they will not cut each other. We can say that they will meet at infinity, right? So at x-axis and z-axis we have infinity, right? At z-axis and x-axis we have infinity, and at y-axis we have 1/3. So let's move toward its table. So we have seen that at x-axis and z-axis we were having infinity, and at y-axis we were having 1/3, right? This is given in that diagram. So then taking reciprocal of it, so 1/infinity, it becomes 3, and it becomes 1/infinity. Then it becomes 0, 3 is 0, and I told you that try to reduce it to the simpler number, so we can divide these all by 3, right? Divide this by 3, divide this by 3, and divide this by 3, right? So if I divide these by 3, so I know that this again will give me 0, and this become cancel out, so it will give me 1, right? So its similar indices will be 0, 1, 0. Oh, sorry, yeah, 0, 1, 0, right? So I can write this as 0, 1, 0, right? This is for plan B. Now if I am talking about plane C, let me select this one, right? So now it's cutting the x-axis here, so if I bring this plane here down, right? Because as we said before that all the plane parallel to this plane will be having the same Miller indices, right? So if I move this plane here, so it's so this point will be shifted here, right? Like if another plane, I am taking another plane parallel to it, so it's this point will be here, and here it is at 1/2, so it will not change, because it is at equal distance from here and from there. So if I bring it here, so it will be also this point will remain here, right? Now let's find it. So then if I take this as my, okay, let me take another color so you will betterly understand. Okay, now this, so I am taking this as again then my origin, and if I move in x-axis, so I know that it is cutting here, right? Because now this the plane parallel to it will be having this point here, so it is cutting at x-axis, right? And it is cutting x-axis at which point? At 1, right? Now if I move in the y-axis, so it is not cutting the plane, right? Because this plane is not parallel to this line. You can see that these line and this line is parallel, so it is not cutting, so we can say that it is meeting at infinity. And if I move in z-axis, right, so we can see that in z-axis it is 1/2, right? It will cut the plane at 1/2, right? So at z-axis it will be cutting the plane at 1/2, right? So at x-axis in 1, at y-axis infinity, and at z-axis 1/2, right? So let's move toward its table. So here we can see that at x-axis it was 1, at y-axis it was infinity, and at z-axis it was 1 over 2. Now taking reciprocal of all these, right, so I will get 1, 0 and 2, right? So this is the mirror indices of that plane, right? 1, 0, 2. Now moving toward the example 6, and this is the last example of today's lecture. So here we again have three planes A, B and C, and we have to find the mirror indices of all these planes, right? So let's get started. So for again the plane A is this one. Let me draw it here, right? This is the plane A. So in order to solve it, let's suppose I am taking this as my origin, right? So if I move in x-axis, right, so it is cutting the plane at 1. Similarly, if I move at y-axis, so it is again cutting the plane at 1, right, at positive y-axis. And if I move in z direction, so here it is also cutting the plane at 1, right? So here we have written for plane A, right? I have mentioned here for plane A 1, 1 and 1. Now taking reciprocal of all these, and we get this 1, 1, 1 as the mirror indices, right? Now let's take the plane B. So the plane B is this one here, and then this one here, right, and then this one, right? So this is the plane B. Now we have to find the mirror indices of this plane. So again I'm taking this as my origin. So if I move in x-axis, so it is intersecting at 1, right? Now if I move at y-axis, so we can see that it is y is equal to 2 here, right? It is cutting at 2. And I move in z-axis, so it is not cutting the plane, so infinity, right? So 1, 2 and infinity, right? Let's see the table. So here 1, right, 2 and infinity. So then again taking reciprocal, 1 over 2, 1 over 1, 1 over 2 and 1 over infinity. So it give 1, it give 1 over 2 and it gives 0, right? So then try, as I told you, that try to remove the fractions. So I will multiply 2 here, right, and I will also multiply 2 here, and I will also multiply 2 here, right? So this 2 and this 2 will cancel out, so here I will just left with 1, and it's become 2 and it's become 0. So the mirror index is 2, 1, 0, right? Now taking the last plane C, so it's this one, right, this plane. Let me show you this plane, right? So now as we have discussed before, that when the plane is at origin, like this plane is at origin, because if I move in x-axis, so it is parallel to the x-axis. If I move at y-axis, so it is again not cutting this plane. If I move at z-axis, so these are again parallel, so they will give 0, 0, 0 mirror indices, right? So what we can do, either we can take a plane parallel to this plane, or in this case if I take this as my origin, right, this point. So now we can easily solve it, right? Like if I move in x-axis, right, so it is not cutting the plane, so it become infinity. Then if I move in y-axis, so this is my positive y-axis, is this one, right? And this one is my negative y-axis, so it will give me -1, right? And if I move in z-axis, so again it is giving me infinity, right? So infinity, -1, infinity, right? So let's move. So here we can see that infinity, -1, right? And infinity, right? So here, let me change it. It may giving me -1, right? This is giving me again -1, and this will give me again -1, right? And so this is given, and the better way to represent it, you can place a bar on it. So its middle indices will be 0, -1, 0, right? So that's it for today. Hope so you enjoy the video. See you in next video. Thanks.